Hello, this is David Birchfield. I'm getting a lot of questions from my students about georeferencing images in ArcGIS Pro. Thought I'd put together a little video tutorial about that. So I am starting ArcGIS Pro. I'm just going to do a new blank map template. I'm going to call it georeferencing. Put it in my folder for my tutorials. And let it create a new folder for this project. Okay, next step is to add in our image that we'd like to georeference. So I'm going to go navigate to that image. You can either do this in Windows File Explorer, or you can do it through the catalog, and I guess I'll show the catalog method because that's an ArcGIS skill that probably should learn. So I'm going to just open this catalog view. It's going to create a new tab up here with my map, and it's called Catalog. Go into Folders. My home folder is called Georeferencing, so it's already in there. I need to navigate to the other folder that has the ungeoreferenced image in it. Okay, so I'm just going to right click on folder, click add folder connection, navigate again to my D drive, and then I'm just going to make a connection to my GIS tutorials folder. And then within that, in that georeferencing folder, I have my Riley 1962 TIFF image. This is a historic aerial photograph that is not georeferenced that I'd like to be able to pull into a map and digitize some features from. So I'm just going to right click on that, click add to map, go back to my map tab. It asked me if I want to build pyramids. This isn't a huge file. It's about 30 megabytes as I recall. So it should load pretty quickly. I'm not real worried about this. And I found that when you go to do georeferencing, sometimes the pyramids can do funny things with how the image is displayed. So I'm going to click no on this right now. After you get it georeferenced, you can always go back and build pyramids, and that's kind of what I recommend with this, because I've gotten some funny things after building pyramids on some of these ungeoreferenced images. So I'm going to click no, and then I'm going to zoom to my ungeoreferenced layer. So this is a state park in Riley County, Kansas, and this is, again, an aerial photo from 1962. If I zoom out, quickly becomes apparent that this image is out in the middle of the ocean. It doesn't have any coordinates associated with it. You can see at the bottom of the screen, I'm at close to 0 degrees north and 0 degrees west and 0 degrees north, and that is off of the coast of West Africa. So what I need to do in order to get that image positioned in the correct place in the world is, it's called georeferencing. We're assigning real world coordinates to an ungeoreferenced image, okay? So I'm going to scroll over to the location that I know corresponds with this, this image. And I'm just going to zoom in on that area. It's Fancy Creek State Park. Okay. Now you can do what's called image-to-image georeferencing, where you are georeferencing an image like the one we have to another image. There's also image-to-map georeferencing, where you use something like a USGS topo quad map as your base map for georeferencing. We're going to go with the image-to-image approach, excuse me, for this one. So what I want to do is make sure that I have this highlighted in my contents pane. The 1962 is highlighted. I'm going to the Imagery tab and then click Georeference. This opens the Georeference tab in here. Now I have all these controls over the georeferencing. Okay, so easiest way to get this image more or less into position so I can fine tune it is to click Fit to Display. Okay. And that's going to overlay, it's going to bring bring our image from 0 degrees north, 0 degrees west to our rough position where it should be compared to our base map. Okay, and I'd like to use NAIP Imagery in order to get a little bit of better precision. NAIP Imagery is 1 meter resolution, and it's going to be fairly current. The most recent NAIP Imagery in this area is about from 2017. So I'm going to add that in and use that as my base map for that image-to-image georeferencing. Okay, so I can go into the Living Atlas. Esri maintains this Living Atlas that has all these different GIS layers that are ready to go, ready to use in your map. And here's the NAIP Imagery natural color. I can also search for the NAIP Imagery in the search box, and I'll bring all the NAIP layers to the forefront. Okay, again, I'm going to right click and click Add to Map on that layer. Go back to my Map tab. I'm going to turn off the World Imagery because I don't really need that anymore. Of course, it's going to have me sign in. Okay, so here it'll load that momentarily, and I always watch the little spinny circle at the bottom and make sure that it's finished before I do anything else. Okay, so right now our Riley County image has disappeared because the NAIP Imagery got put on top of it, so I'm just going to drag it above that. Okay, so now it's time to start introducing control points. Control points are reference points that connect the ungeoreferenced image to the base map. Okay, so in order to add control points, I'm going to click Add Control Points, that button right there. And then I'm going to find places that I can use as control points. So if I look, I want to find places that are intersections of lines where I can have distinct corners, basically, that are small in size to use as my control points. The larger a feature is, the more difficult it is to use it precisely as a control point. So I'm just going to zoom in and look for some features that I can use as control points. And those could be rocks. They could be trees. Trees tend to change over the 60-year period or so that that passed since this imagery was collected. So trees might not be the best idea, but usually roads or rocks, boulders are good features to use because they're small and distinct features. Okay, so what I like to do is kind of flicker my old photo, my ungeoreferenced photo, on and off, and start looking for places that I can use as match points. Okay, so I'm going to use this road intersection here. I think this is going to be a pretty good control point location. I'm just going to zoom in, and this little corner here is fairly distinct, so I'm going to click on that, the very corner of that in my historical aerial photo. Then I'm going to look for the approximate same location on my base map. Okay, it looks like the road, right away here, the side of the road is kind of gravelly, rocky in the old image. In the new image, it's kind of become overgrown with grass. So I think the point that I clicked on the old image is actually about right here in the new image. So I'm going to click that. You notice that the whole image has shifted over to match where I clicked. Okay. So wait for this to load. Okay. So another place that I think is going to be a decent control point, we don't have a tons of options to choose from, is if we look at this bridge. This is a bridge right here, and it was actually built in 1962. We have a very distinct intersection between the road and the shadow that the bridge is making. So I'm going to click on the very corner of that shadow, and then I'm going to do the very same thing in my NAIP imagery. It's about right there. I turn on my historical aerial photo again. The bottom should be pretty close. Notice that those roads line up really nicely along the bottom. Top is a little bit off still, so we're going to have to put in another control point or two to fix that. Okay. So if I zoom in here, notice that this road is present in the historical aerial photo. But there's this little fork, the left fork of that road, that has become overgrown, and it's been neglected for many years. So, but I think I can find the point where that old fork came off of that road. I think it's about right here. So I'm going to click roughly where I think that should be in the old photo, and roughly where I think it should be in the new photo. Okay. As I click back and forth, the road more or less aligns. It's not perfect, but you have to ask yourself what's good enough on these sorts of things, and we'll add in a few more control points. The other thing that is a good control point is some of these rocky features. Sometimes you can see those in the old versus new imagery. So I'm going to click back and forth and see if I can find any rocks or anything that seem to still be present. Oh, I think I see one right here. So this rock right here is the same as this rock right here. So I'm going to use that as a control point. Okay. Now you notice that there's a little bit of an offset between where I clicked and where the georeferencing model thinks at that point should be. Okay. So what happens is there are these different transformations that are applied to your image to make it fit into place as you add those control points. And basically, the higher order polynomial equation that you use to adjust your image, the more complex that formula is. Okay, and so we want to go with as small of a polynomial equation as we can, just as a rule. So I'm going to just keep it with first order, and then I might try second order, but a lot of times I'll just keep it as first order polynomial. Okay. The georeferencing is looking pretty good, and I can probably add some more points and refine it further, but that just involves putting in more control points. Okay. Another thing you can do that is really helpful is adjust the transparency of your ungeoreferenced image, so you can kind of see through it. There's also a swipe tool, so I can kind of swipe back and forth and see how close I am to my georeferencing. There's also a flicker tool, so I can quickly turn that image on and off, flicker it on and off, and I can turn up the speed if I want to. Okay. So if I wanted to make it faster, I could do 100 milliseconds, and that's going to do much quicker flicker. So it's a good idea to have as many ground control points as you can, and the other important tip is to have them as well distributed across the image as possible, particularly within the corners. If you think of this, we often use the term rubber sheeting, and rubber sheeting just means that if you were to have a sheet of rubber material and you were to fit it over a surface, you're going to have to stretch and warp that rubber to fit over the surface. And that's basically what we're doing here, using a mathematical model of rubber sheeting this image onto this base map. And so the more points, the more well distributed our control points are across the image, the better that rubber sheeting algorithm is going to work. And so it's best to have control points, particularly along the edges and the corners of the image, to kind of pull it tight if you think about the rubber sheet. So I'm going to just add a couple more control points I may just fast forward through this because it's really the same that we've done before. The other thing that having more control points is going to give you is more options in your transformations. If I wanted to go to a second or third order polynomial transformation, I've got to have 6 points for a second order and 10 points for a third order. And there are these other ones, spline and projective and adjust, that require more control. Well, adjust requires the same amount as the first order, but projective and spline require more control points as well. So I'm going to try to get 2 or 3 more so I can get into that second order range. Here's another one that I can use. This is a rocky outcropping here. By the way, another handy feature in ArcGIS and ArcGIS Pro is that you can, when you're in any tool that isn't the Explore tool, this is your standard tool, the Explore tool. When you're, it looks like a hand, and it basically allows you to pan across the map and click to drag. Is how it works. But if I'm in a different tool, there are a gazillion different tools in ArcGIS that you can use. If I'm in one that's not the Explore tool, I can click my mouse wheel, and that lets me drag my map around, pan around, just as if I'm using that Explore tool. So again, I'm looking for rocky outcrops. There's one right there that kind of gives you a corner of the rocks that you can use for something about right here. Corresponds to right here. Okay, so I've got plenty of points over here. Let's try to find one on this side if we can. It's going to be a little tougher because this is up against the river, and this is the part that's probably seen the most change in this amount of time, in this time period. Really not seeing anything too promising. This road is roughly the same one that has the S-bend in it, but I'm not seeing anything that I can confidently use as a control point, unfortunately. And that happens sometimes. You just have to do your best. This is a process that requires a little bit of detective work in some cases, because landscapes change a lot over 50 years. And that's part of the fun of it, I think. So, try up in this area. There's some of those rocky outcroppings again. Okay, so here's one you can use. Zoom in a little bit more. The closer you zoom, a lot of times, the more precision you're able to get. That corresponds to this rock right here. All right. So I'm going to call that good. I can apply a second order polynomial now that I have, what, seven control points. So I'm going to go into my control point table and my residuals. Oops. Now, if you accidentally click on the map and you don't want to lay a control point in that spot, you can hit the escape key on your keyboard, and that'll make it go away. Okay, so I've selected that. That has a high residual, so it doesn't fit in the model very well. If I apply that second order transformation, that greatly reduces my residuals. Now, you have to be careful because you can do what's called overfitting the model, and you're basically using a more complex mathematical equation to make this image fit to your control points, no matter what. And it's kind of cheating. It doesn't always work great because you introduce some error, some kind of false points in there. So that's why I don't like to go to those higher order polynomials as much. So you do introduce that error. Okay. All right. So now that I have enough control points to do a second order polynomial, my residuals are down pretty low and certainly within an acceptable range. So I'm going to call it good. And the next step is to export this image as a georeferenced image. And the way that you do that is simply by saving it. When you save it, it's going to place a TFWX file like this. I've already saved this image, so it's already written this TWFX file. And if I open that with Notepad, I can see that it's got some coordinate information in there. That's what that world file does. Okay, so all we have to do is hit save. It's going to write that TFW file, and that means that the georeferencing has been completed. The other option that you have is to leave your original file ungeoreferenced, and you can do save as new. Click save as new, and this is going to make a georeferenced copy of the original. Okay, so you'll end up with a georeferenced image and the original image that stays ungeoreferenced. Okay, so there might be situations where you would want to do that, but I usually just save the original. All right, so when you're finished, you can click close georeference, and it is going to close this ribbon, and it's going to get rid of your control points on the screen. So now you have your georeferenced image all finished. Now I can go through and draw graphics on the screen, or I can create a shapefile or a feature class and digitize features of interest on my map. And that's, that was my goal with this, was to be able to do some mapping on this historical aerial imagery. So thanks for watching. Let me know if you have any questions in the comments below, and I'll try to keep these tutorials coming as my students keep asking questions about how to do these sorts of tasks. Thanks again for watching, and take care.